Okay, so if they cross at one point, you have one solution. Okay. If you have two lines that are parallel or have the same slope, you have no solution. There's no common x and y coordinate. So you have no solution in this case. And then the last case is if you have two lines that literally are the exact same. So you can notice I'm not really like, I'm trying to draw it like really close to it to kind of represent that it's two lines that are literally smack dab on top of each other, even though it's like, you know, if you were really to look at it in real life, it's like, would look like one line. But I'm just trying to show that they're pretty much right on top of each other. That's also why I'm using color. Okay, so infinite solutions. Okay. So we're going to call this part solutions on graphs. Okay. Let you guys. All right, so now, again, we're going to be answering the question, what type of solution? And this time we're going to look at equations. So I'll have an example here. I'm going to put one right next to it like this. So the first example, I'm going to write down both equations side by side, and then we'll go over them. So the first one's y equals 4x minus 6. Then x minus y equals negative 9. The second equation is going to be y equals negative 4x plus 7. And then 8x plus 2y equals 17. Pause it for a second. All right, so here we're just basically going to solve the equation, and that's going to help us determine the type of solution, but we're not going to solve it all the way through because we don't need to solve it all the way through to figure out the solution, okay? So starting with these two equations, they have one equation with y equals. They both have one equation with y equals. They both have that. And if you guys remember back from when we were solving equations like this, and I'll come back, let me just review something. You know what, let me go back to my other notebook. When we had both or one equation with y equals, we did substitution. We took this part, we plugged it into the other equation, and then we simplified and solved for that first solution. Okay, and then we had the other situation, which was equal values, where we had both y equals, and we just made them equal. The third one was elimination, where we needed opposites. We needed the opposites to cancel out a variable and solve for the first, you know, x or y solution. Okay, so we have substitution in this case. One is y equals, so that means we're going to take the 4x minus 6, and because it equals y, that's where we plug it in to y. Now, what's important to remember is that, especially when we just have x and just y, that's not just x and y, that's actually a 1. 1x and negative 1y, okay? So let's go ahead and plug it in. So now 1x minus 1y, oh, sorry, not 1y. We're replacing the y or substituting the y. We're going to replace that with 4x minus 6 equals negative 9. Okay, and from here I'm going to draw my line, okay, to keep myself organized. So the reason I put that 1 is because I got to remind myself that I got to distribute that negative 1. So I can distribute the negative 1. So now I get 1x minus 1 times 4x is negative 4x. Negative 1 times negative 6 is positive 6. Okay, now on the left, I can combine like terms. So 1x minus 4x is negative 3x. Now I want to start isolating the x by taking away this constant or this number. So subtract 6 on both sides. That cancels out there. Negative 3x equals, I'm adding two negative numbers, so that means I'm going to add them. So negative 9 minus 6 is negative 15. And the last step here would be divide by minus 3. So negative 15 divided by negative 3 is positive 5. Now, what does this mean? Because remember, we're not just looking for x and y, we're looking for what type of solution do we have. Well, if I got an x equals 5, that means I have a solution. And there's only going to be one. So I don't actually need to find y in this case, because all I need to know is there a solution at all? So in this case, we have one solution. Okay. Now, same steps on the next one. Same exact steps, because they're both set up the same way, just different numbers, right? So circle that one. I'm going to plug it in here. I'm actually going to pause for recording again. So now we're going to plug in that equation. So now 8x plus 2 times negative 4x plus 7 equals 17. Let me draw my line. Stay organized here. Okay, you distribute the 2. So now I get 8x. 2 times negative 4x is minus 8x, or negative 8x. And then 2 times 7 is positive 14. Nothing changes with the 17. Now again, I'm going to combine like terms just like I did over here. 8x minus 8x. And some of you guys might notice already what happens to those two terms. They cancel out because they're opposites. So all I am left with is 14 equals 17. There's no more variables to solve for. So obviously that's a problem. Now the first question you got to ask yourself, is that true? Does 14 equal 17? No. So if it's not true, this means it's going to be no solution. There is no solution to the equation. Now, like Andy was asking, could you actually solve for y on the second equation and do what I did here in that example? You could. You could actually do that. You could do that and then graph it. Of course, do you want to rearrange the equation and graph it and then figure out the solution? Or do you want to do this method? It's kind of like you got to kind of choose which one's the best way to go about it. All right, but most of these cases, especially for the worksheet, the couple problems you got to do, I would take this would probably be the simplest way to figure that out, okay? All right, so let's look at a couple more examples. If you need more room, you run out of room, just go to your next page. Let me zoom out a little bit so you guys can see that all. Okay, I'm going to do example 3 down here and 4. They're a little shorter, the example 3 and 4, so you don't need a ton of room at the bottom here. It's only going to be like an inch of space that you need, so you don't need a lot, in case you're wondering. Okay, so here I'm going to have two equations now in standard form, where I have x, y equals a number, and here I have 3x minus 4y equals 3. And then the second equation is going to be the same thing, 3x plus 4y equals 5. And then 3x minus 4y. The only thing that's going to be different is that last number, negative 5. Okay, so same equations. The only thing different is these two numbers here. Okay, so let me pause the recording, give you guys a chance to. Now I've got two equations in standard form. Two equations in standard form. So if they're both in standard form, well, that goes back to what we did last week, elimination. Okay, so here I got opposites. One's negative, the other's positive, and they're the same number, so they'll cancel. And then the other numbers I add up. So here, on this first one, we'll have negative 3x and positive 3x, cancels. So then I have 4y minus 4y. Well, wait a minute, that also cancels. The only thing that doesn't cancel is the 5 and the 3. Now remember, when we say cancel doesn't mean like things just, fade off into oblivion and there's nothing left. Cancel just means that it all equals 0. Okay, so because negative 3x plus 3 is 0, and 4 minus 4 is 0, so we write 0. Okay, then here it's 5 plus 3, which is 8. So now again, I've got another untrue statement. 0 does not equal 8. So again, no solution. So once you get two numbers that don't equal each other, no solution. All right, next one. Same situation. Cancels, cancels. Over here, 5 minus 5 is also 0. So technically that cancels. So that means on the left, I've got 0. And on the right, I have 0. So the only difference between this one and these two is that 0 equals 0 is a true statement. That actually is true. 0 equals 0. So in this case, this is going to be infinite solutions. Infinite. Okay, so which basically means that these are two equations. If I graph them, they would look like that. So if you graph these equations and it's no solution, that means you got both of these are parallel lines. If you got one solution, that means it's going to look like this if you graph those two equations. And the same thing here, no solution means both of these would be parallel to each other. If you guys graph those in Desmos, that's what you would see. All right, so if we have x equals a number or y equals a number, we've got one solution. So as you're solving it, as long as you get x equals something or y equals something, we got one solution. If you get an untrue statement like 5 equals 3 or 0 equals 10 and it's not true, we're going to have no solution. Because basically all that means is the lines do not cross. They do not intersect. There's no common solution between those two. And then the last situation you would end up with is two numbers that are equal. 5 equals 5 or 0 equals 0. That is true. And that's when we're going to have infinite solutions. Okay, let me pause the video for a second.